The question is, could you do an example on the calculation of nail spacing in a built-up beam? And for this particular example, I'm going to use a T-beam, which is non-symmetric about the z-axis. Here is the problem description. We have a T-beam constructed out of two boards like shown in this picture. One board forms the flange, the other board forms the web, and they are fastened together by nails like shown in the picture at a spacing of S. Each nail can resist a force of 2 kilonewton, and we are to determine the nail spacing of S to support a shear force of 20 kilonewton acting on the cross-section like shown here. The first two steps of solving a problem like this are, number one, find the location of the centroid, and number two, find the second moment of inertia of the cross-section about the z-axis, right? In this problem, they are given to us. This distance is 120.5 millimeter, where z-axis is placed right on the centroid C, and the y-axis, of course, go through the centroid again in a vertical direction. The I, the second moment of inertia about the z-axis, is 0.648 times 10 to the minus 3 meter to the power of 4. So this allows us to focus just on the calculation of the nail spacing S. Let's talk a little bit about the theory. I'm assuming that at this point you know how to calculate the shear flow for built-up beams. In order to design the nails here, we need to calculate the shear flow on this horizontal plane that connects the flange to the web. Remember, shear flow is the shear force per unit length, right? So here are some details of how we connect the shear flow to the nail spacing, little s. And here, little s is the nail spacing. F is the force that a single nail can withstand. In other words, that is the strength of a single nail. Since shear flow is defined as the force per unit length, let's go ahead and figure out how many nails we will have over a length of 1 unit. The meaning of the spacing, little s, is that we have just one nail over a length of s units, right? And therefore, the number of nails over a length of 1 unit would be 1 over s times 1. So this is, let's call this as little n. Since the strength of one nail is F, the total strength of nails over a length of 1 unit would be F times n, right? So that's F over S. And then F over S, therefore, must be equal to little q. And little q is given as VQ over I. So this is the connection between the spacing S and the shear flow, little q. Now rearranging this equation, we get this equation for little s. V is given, I is given, F is given. We just have to calculate Q. So this is the key in solving problems like this. We are interested in finding the shear force on this horizontal plane between the flange and the web, and therefore the shaded area to be considered would be this right there. Q then is A prime multiplied by Y bar prime, where A prime is the area of the shaded area and Y bar prime is the distance to the centroid of that shaded part from the z-axis, right? So here are the details. You can easily follow the numbers, so I'll let you do that. We get a value of 2.39 times 10 to the minus 3 meter cube for Q. Now all we have to do is to substitute these numbers into this equation in order to calculate the nail spacing. So S equals Fi over VQ, F is 2 kilonewton, I is 0.648 times 10 to the minus 3 meter to the power of 4, V is 20 kilonewton, Q is 2.39 times 10 to the minus 3 meter cube. So this gives us a spacing of 0.0271 meters or 2.71 centimeters.